to my video on theoretical and experimental review classwork. So question number 1 says, if a coin is flipped 120 times, how many times would you predict that the coin lands on heads? Well, we know that you're supposed to land on heads half the time because the probability of landing heads on a coin is 1/2. So there's a number of different ways you can do this. You could just figure out what half of 120 is. So half of 120 is 60. Another way of doing this, since you're taking half of a number, you could divide it by 2. Or yet another way is to say, okay, the probability is 1/2. Okay, so 1 out of 2 for heads. So this would be heads, and this would be your total. Okay, and then if you flip the coin, or total flips, if you flip the coin 120 times, how many times would you expect to land on heads? So you could solve a proportion. 2 times what is 120? 60, and 1 times 60 is 60. Or you could actually just solve this proportion. So this is a quick review on solving proportions, as you may have seen in the last classwork video that you watched. So 2 times x is 2x, and 1 times 120 is 120. And the opposite of multiplication is division, so we divide by 2. And 120 divided by 2, of course, is 60. Okay, number 2. A coin is flipped 30 times. What is the experimental probability that the coin lands on tails? So I notice there's 14 tails. And how many times did we flip the coin? It was 30. Now, if they didn't tell us that it was 30, then we would have to add these two together to get the number of times that we did the experiment. Okay, I notice they're both even, so I can divide top and bottom by 2. And 14 divided by 2 is 7, and 30 divided by 2 is 15. So the answer is 7/15. Always, 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 when they're asking a probability, always make sure you simplify your fraction. And when they're asking for a probability, they're always looking for generally a fraction, but sometimes your answer will be expressed as a decimal, or sometimes it might be expressed as a percent as well. Okay, but if you see what is the probability, just assume they're looking for a fraction unless it states otherwise, or unless it's multiple choice, and the multiple choice answers are decimals or percents. Okay, number 3, Camden has a bag of marbles. Okay, you already did this problem, so I'm not going to read everything to you. It says, what is the experimental probability of choosing a blue marble? So this is what's in the bag, so that's the theoretical. This right here is the experimental. So I got to look at the chart for the experimental. So blue is 10 out of, I don't know how many times they did it. It doesn't tell me how many times, so I'd have to add this up. And that, of course, adds up to 60. So it'd be 10 out of 60. But I know that's not simplified. They both end in a 0, so I know that I can divide by 10. 10 divided by 10 is 1, and 60 divided by 10 is 6. So the probability, or experimental probability, of blue is 1/6. Letter B asks for theoretical of choosing either green or orange, so I have to count those together. So that's what's supposed to happen. So that's what's in the bag. So let's look to see what's in the bag. I have 1 green, so there's my 1 green there, and I have 1 orange. So that's how many choices? 2. And how many marbles are in the bag? I have 1, 2, 3, 4, 5. When I count the marbles in the bag, I have to count the ones that I'm choosing as well, because that's the total amount of marbles in the bag. And 2/5 cannot be simplified. What is the theoretical of choosing a marble that is not orange? So I have to count all the ones that aren't orange. Okay, so 1, 2, 3, and 4. So it's 4 out of 5 that are not orange. Another way of doing it too, since we know there's 5 marbles, just subtract the ones that are orange to find out the ones that aren't orange. So 4 out of 5 cannot be simplified. Okay, it says, for which marble does the experimental equal the theoretical? Okay, so this one's a little tricky. Okay, the theoretical of green is 1/5. They're all 1/5, right? Black, red, blue, orange, and green. Okay? So we got to figure out which one would simplify to 1/5. Okay? I knew blue isn't going to simplify to 1/5. I already got 1/6. But I noticed 1/6 is really close to 1/5, so it's got to be something close to it. Okay? Now, what I can check too is I know that 1/5, if I check the decimal for that, is 0.2. Okay? So I'm looking for a fraction that gives me 0.2. So let's see. Let's just check black 14 divided by 60 is 0.23. 0.23 repeating, so that'd be about 23%. Nope, not going to cut it. Okay, 9 out of 60 is 15 hundredths, which would be about 15%. No, not going to cut it. Already did blue. Let's see, green, or sorry, orange is going to be 15. That's going to be too many because I know 14 out of 60 is 0.23, so 15 isn't going to work because that's about 0.25. So let's try green. 12 out of 60, and if I type that into my calculator, it gives me 0.2. So the correct answer is green. That's how you would figure out that question. That one was a little tricky. Okay, let's turn to the back and I will go through these quickly. The first one is probability of 4. It is not 4 out of 6. There's only one 4 on a die, so that's 1 out of 6. A probability of a 3 or a 5. That's 2 choices out of 6. So if I divide top and bottom by 2, that would give me 1/3. Probability of not 6. Well, there's only one 6 on a die, so that would mean there are 5 that are not 6. Okay, and another thing I probably should have told you is you can actually write these out so you can see them a little better, and I'm going to write it out for this last one. Okay, a prime number. Remember, prime numbers only have factors of 1 in itself. Well, 1 can't be prime because it only has one factor. It's got to have factors of 1 and itself. Okay, this one is prime. Okay, because it has 1 and 2 as factors. This is prime. 1 and 3. This is not prime because it has factors of 1, 4, and 2, because 1 times 4 is 4, and 2 times 2 is 4. So that would be 3 factors, because I only count 2 times 2 as one number. Okay, I only count it as 1, 2. 5 is prime. Only has factors of 1 and 5. And 6 is not prime, because 1 times 6 and 2 times 3. So that actually has 4 factors. Okay, so let's count them up. 1, 2, 3 out of 6, which simplifies to 1/2, because I could divide top and bottom by 3. So that would be 1/2. If the die is rolled 300 times, how many times would you predict a roll of 1 or 6? Well, I know that the probability of rolling a 1 or a 6 is 2 out of 6. And what is that simplified to? 1/3, because I can divide top and bottom by 2. So the probability is 1/3. So I could take 1/3 of 300. And remember, taking 1/3 of a number is the same as dividing by 3. So 300 divided by 3 is 100. So it'd be 100 times. Okay. I also, now I'm not going to solve it this time, but I'm also going to show you that I could set up a proportion, 1/3 and x over 300. And even if I didn't simplify, if I used 2 over 6 equals x over 300, it's still going to come out to be 100 times, no matter what. Okay, number 5, Jack rolled the die 36 times. What is the experimental of landing on 5? So here's the number of times he landed on 5, 3. And I have to add these numbers up. So 5 plus 7 plus 8 plus 6 plus 3 plus 7. And that gives me 36. So 3 out of 36. And I notice that I can divide top and bottom by 3. 3 divided by 3 is 1, and 36 divided by 3 is 12. So it's 1/12. For which number on the die did the experimental equal the theoretical? Okay, well, the theoretical is 1/6 of all these numbers. That's what you're supposed to have. But when you roll a die, you're supposed to get it number 1, 1/6 of the time, 2, 1/6 of the time. Okay, so I got to figure out which one of these is 1/6. Well, I know that I'm doing it 36 times. Okay, so I could set up a proportion. So 6 times what is 36? 6. So 1 times 6 is 6. Okay, and I'm not going to show you how to solve this proportion. I already showed you earlier in the video how to solve a proportion. So I'm looking for one that landed 6 times. So let's look. Looking for a 6. There it is. What number is that? That is the number 4. So that was another pretty tricky one. And the last section here, I'm going to blow right through this. This hopefully was easy. Black would be 1 out of 4. Orange would be 1 out of 4. Blue or purple, I have to count both of them, so that's 2 out of 4. And I could divide top and bottom by 2, and that would give me 1/2. And the probability of not purple, there's 3 out of 4. So that concludes my video on theoretical and experimental review. Please let me know if you have any questions. Have a great day.